Yeah. I'm going to give you 3 minutes again. Please do this one quickly. Right. Here we have three recurring decimals. First of all, you're going to take them and let it be equal to x. Because we've got three recurring decimals, we will multiply the first equation by 1,000. Please note that the recurring decimal is 214,214,214. Right? So you're going to multiply this first equation, the expanded equation, by 1,000 because we've got three recurring decimals. So our decimals are after the comma. Now, we're going to multiply both sides by 1,000 to get equation 2. Then you're going to take equation 2 minus the expanded equation 1. And when you do that, remember to start at the left-hand side, and you will take 1,000 minus 1, which is 999. And on the right-hand side, you have 1,214 minus 1, which is 1,213. Then you divide both sides by 99. Simplified form, it will be 1 and 214 divided by 99. Try this one quickly. Please note that with respect to this one, we've got a 2, which is the first decimal, and 2 is not recurring. To move it before the decimal, we will have to multiply we first multiply by 10 because we're just moving one decimal, and we're just moving it once, which will give us 32,585858, and then on the left-hand side, it will give us 2. Now, from this equation, we realize that we've got 2 recurring decimals, which is 5858. It means that to get equation 2, we're going to multiply equation 1, which is the 10x, is equal to 32,58 by 100. Now, 10 times 100 will give you 1,000. 32,5858 will multiply that by 100. It'll give you 3,258,585. So we take equation 1, subtract it from equation 2, and that's what you will get. Divide both sides by 990, x will simply be equal to that, which is your common fraction. Remember, once you have moved the decimal, you come with the original equation that you found, which is 3,25858. Now you're going to be doing irrational numbers. Obviously, guys, you know what irrational numbers are. Irrational numbers are numbers that we cannot express as a fraction. And these are numbers are infinite. They're non-recurring decimal fractions. And I give you examples such as the square root of 2, square root of 7, or square root of 2 over 4, etc. Because 7, 2, and 3 are not perfect squares. So basically, there's no way we can find the square roots of those. Similarly, if I find the cube root of 12, cube root of 100, those are not perfect cubes. Therefore, they will result in me getting a non-recurring decimal if I were to simplify them. We're going to start by defining what a perfect square is. A perfect square is a product of 2 identical factors. I repeat, a perfect square is a product of 2 identical factors. For instance, if you take 2 times 2, it'll give you 4. 4 is a perfect square. If you take 3 times 3, it'll be 9. 9 is a perfect square. Okay, give me another perfect square. What comes after 9? It's 4 times 4, which is 16. What comes after 16? 25, and then 36, and then 49, and then it goes on and on. All right. After 64, you will have one, let me just remember this. It'll be 81, yes, which is 9 times 9, because 64 is 8 times 8, right? What is a perfect cube? Note that a perfect cube is identical to the definition of a perfect square, except here we multiply 3 identical factors. Okay, now if you multiply 2 times 2 times 2, it'll give you 8, meaning that 8 is a perfect cube. 3 times 3 times 3, it'll give you 27, which means 27 is a perfect cube. What comes after 27? 64, after 64, 125, after 125 is 216, after 216 is 343, and after 343 is 512, and then it goes on and on. Okay, those are examples of perfect cubes. Now here's one question here where they will ask you between which 2 integers do the following irrational numbers lie. For instance, I'll give you the square root of 10. Between which 2 integers? We're looking for integers. Will the square root of 10 lie? That's what we're trying to find. Now here is how you are going to do this. You are going to find a perfect square. The first perfect square, the first one, to be less than 10. The first perfect square to be less than 10. It is 9. Okay, you can 2 will be the second perfect square to be less than 10. 9 will be the perfect square that is the first one to be less than 10. Which perfect square will be greater, will be the first one to be greater than 10? It is 16. Now you're going to put the square root of 10 between the square root of 9 and the square root of 16. But the square root of 10 will be greater than the square root of 9, and the square root of 10 will be less than the square root of 16. Then you simply find the square root of 9. What is the square root of 9? It is 3. And what is the square root of 16? It is 4. Which means that the square root of 10 lies between 3 and 4. Why did I look for a perfect square? It's because I'm given a square root. So when you are given a square root, you look for perfect squares. If you are looking for a cube root, you're looking for a perfect cube. Let's check here. Please note that here we're dealing with negative 10. So you're going to ask yourself, which perfect square, the first perfect square to be less than 10. And you realize that the first perfect square to be less than 10 will simply be 16. Why am I saying 16? Because that square root will be negative. And in this case, the negative square root of 16 will be less than the negative square root of 10. And the perfect square to be greater than 10 will simply be 9. That is because the negative square root of 10 will be less than the negative square root of 9. In this case, you just find the square root of 16 and 9. That will give you negative 4 and negative 3. Meaning that the negative square root of 10 lies between negative 4 and negative 3. which product here will be a result of three identical vectors multiplied. We start with the first one that will be less than 5. Perfect cube less than 5 will be 1. And a perfect cube to be greater than 5 will be. Right, let's see if you're right. Now you need to find two perfect cubes. One must be less than 5, the other one must be greater than 5. The one less than 5 will be 1 is outside, the one greater than 5 will be 8. So you just find the cube roots of those two. You will simply get 1 and 2. So meaning that the cube root of 5 lies between 1 and 2. If you have an ABC textbook, please try these ones. Now, which two integers do the following irrational numbers lie? Now here we have the fifth root of 2. Try it out. I'll give you 3 minutes. Now, which number will be a perfect fifth root that will be less than 2, and which number will be a perfect fifth root that will be greater than 2? Less than 2, there can only be one, which is 1. Greater than 2 will simply be 3. And you just find the fifth root of both, so we'll get 1 and 2, and the fifth root of 2 lies between 1 and 2. Try this one. Square root of 66 to perfect. We want to choose perfect roots. In this case, a perfect root that is less than 66 and a perfect root that is greater than 66. Less than 66, we will have 64. Greater than 66, we will have 81. 81 will give you a perfect square root, which is 8 and 9. Try this one. For this one, we'll have following greater than 23 will be 25, less than 23 will be 16. Square root of 23 will lie between 4 and 5. And here you have 27 as well as 16. And that will be it for me. Let me just see if I have an extra thing that I can put in. No, I don't. Basically, that will be it for me. Let me just see if I can include something here which summarizes everything. Let me try this out. There's a table. Yes. Quickly draw this table and simply take the appropriate column. For instance, if you have negative 2 over 3, that is simply a rational number. So I'll just click on the rational numbers. And it is also a real number. If it's a rational number, it is also a real number. 0 is a whole number. It is an integer. It is a rational number. It is a real number. Note that a number cannot be irrational and rational at the same time. It can only be one. Okay, please do the rest. All right, that's it for me. Let's check here. I hope you got those right. And with a little bit of summary that you can read through and make sure you understand everything. I wish everything of the best when it comes to number systems. I have covered number systems up to grade 10 level. You should be okay until you get to grade 10. If there's anything you don't understand, don't be scared to send me an email or simply send me a WhatsApp or simply join the classroom, Google Classroom, and ask the question. Awesome.